Good morning, dear students. Yesterday we have discussed the topic of quantum mechanics, in that black body radiation, and there are three expressions like Wien's expression, Rayleigh's expression, and Planck's expression for the black body radiation. And next is wave particle dualism and also the de Broglie hypothesis. Okay, today we will discuss Heisenberg uncertainty principle. The statement of this principle is, it is impossible to determine both exact position and momentum of a particle simultaneously or precisely. But the product of uncertainty involved in the measurement of position and uncertainty involved in the measurement of momentum, which is greater than or equal to h divided by 4/5. It means we cannot find the exact position and exact momentum of the particle. For example, in molecular scale, the electron, since electron is very fast moving, we cannot find its position and momentum simultaneously. So that simultaneous determination, it is not possible. So if we want to find the position and momentum, one, we have to take the uncertain value. Uncertain means which is not sure value. Okay. For example, here I have considered delta x. X means it is the position, and delta means it is change, or delta x is the uncertainty involved in the measurement of position, and similarly the delta px, it is the uncertainty involved in the measurement of momentum. Okay, by mathematically we can write it is delta x into delta px, which is greater than or equal to h divided by 4/5, where delta x is uncertainty involved in the measurement of position and delta px is the uncertainty involved in the measurement of moment. Similarly, this Heisenberg uncertainty principle, which is also extended for energy and time, and next is angular momentum and angular displacement. By mathematically we can write it is delta E into delta T, which is greater than or equal to h divided by 4/5. Similarly, the delta L into delta theta, which is greater than or equal to h divided by 4/5. So energy and time we cannot find at simultaneously and precisely. The same thing, angular displacement and angular momentum we cannot find at the simultaneous process. Okay, now the physical significance of Heisenberg uncertainty principle. It means, so as per the principle, it is stated that it is not possible to determine exact position and exact momentum simultaneously. Suppose if you want to find the exact position, like delta x, which is tends to x, exact position means x. If you want to find exact position, then another aspect, that is momentum, will be uncertain. So one is certain, another thing, it becomes the uncertain value. Similarly, if you want to find the exact momentum, that is delta px tends to p, then another aspect, that is position, it becomes the uncertain or more uncertain value. So this is one standard chain like delta x and delta px, which is greater than or equal to h divided by 4/5. Next is application of uncertainty principle, in that non-existence of electron in the nucleus, and this can be studied by taking the beta ray emission. So as we know that during radioactivity there are three kinds of radiations are going to emit. One is alpha rays, beta rays, and gamma rays. In 1900, the scientist Becquerel, who proposed that these beta rays, like emitted beta rays, are actually, it is the streams of electrons. And later it was found that the electron which constitute of beta rays and emitted with the different velocities and corresponding kinetic energies ranging from 3 to 4 mega electron volts. So first it was stated that beta rays, which is nothing but it is electron, but after so many investigation, it is confirmed that these electron which is constituted of beta rays. Now the question is it possible that electron is exist inside the nucleus with certain energy, and the same energies appears as their kinetic energy when they are emitted? Suppose if electron is inside the nucleus, then electron energy must be less than 3 to 4 mega electron volts. Okay, now this can be proved as follows. So as we know that the energy equation, because first we need to study the energy of electron, right? So if electron energy we can get, we'll discuss the cases. So if electron must be inside the nucleus, means its energy, it should be less than 3 to 4 mega electron volts. So the energy in terms of momentum, it is given by E, which is equal to p square divided by 2m. So where p is momentum and m is the mass of an electron. So it is equation 1. And also we know that the Heisenberg uncertainty principle, so that is delta x into delta px, which is greater than or equal to h divided by 4 pi. Delta x is uncertainty value of position and uncertainty value of momentum is delta px. And I can write it as delta px, which is greater than or equal to h divided by 4 pi into delta x. And we also know that the typical values of radius of the nucleus, so the radius of the nucleus value is 10 raised to minus 14 meter. Suppose if electron is present inside the nucleus, means the maximum uncertain value of electron is 10 raised to minus 14, because maximum displacement it can travel, the electron is 10 raised to minus 14 meter. So I can consider this is the uncertain value. Therefore the position of electron, I can write it by delta x is less than or equal to 10 raised to minus 14 meter. Okay, now the delta px we can calculate. So delta px, which is equal to, substitute the value, like h is 6.625 into 10 raised to minus 34 divided by 4 into 3.142 into radius value, that is position value, that is 10 raised to minus 14, and resultant value, that is delta px is 0.52 into 10 raised to minus 20 Newton second. So as we know that the physical significance of the Heisenberg uncertainty principle, suppose if you want to find exact position, another aspect will be uncertain, like momentum will be uncertain. So in this case we have taken delta x as uncertain value, therefore the another resultant momentum will be minimum or certain. So that I can write, instead of delta px, I can write it by px, because already delta x is uncertain value and delta px becomes the certain value. So it is 0.52 into 10 raised to minus 20 Newton second. Now we can substitute this momentum value in energy equation. So we will get p square by 2m, substitute the value. So we will get the energy in terms of joules, that is 1.52 into 10 raised to minus 11. And expressing in terms of electron volts, because our discussion is in terms of electron volts. So substitute this, we will get energy as 95.3 mega electron volt. So energy is greater than or equal to 95.3 mega electron volt. So this means that if electron is present inside the nucleus, this energy must be greater than or equal to 95 mega electron volt. But the experimental investigation on beta decay reveals that the kinetic energy, it is less than 3 to 4 mega electron volt. So it is not possible. So which clears that, or which clearly indicates that the emitted electrons cannot be exist inside the nucleus. Hence the proof.